Hey guys, this is Mr. Peterson, and I'm going to show you all my Rube Goldberg video. We're going to run through it twice. The first time I will pause, interrupt, and point things out, what's happening, what simple machines are being used, some of the physics involved. It's by no means comprehensive, but there are a few explanations in there, what's going on. And then after I finish that, we'll watch it all the way through from beginning to end. Okay, so machine starts when I pick up the book, and the first simple machine we encounter is an inclined plane or a ramp. Pretty straightforward. All that's happening here, remember your potential energy, which is the mass of the object times gravitational acceleration times height, is being converted into kinetic energy. Remember, kinetic energy is 1/2 mass times velocity squared. So as this object, the tennis ball in this case, moves from a higher location to a lower location, it is changing energy from potential to kinetic. The next type of simple machine we encounter is this sort of domino series. The keen observer will notice that these are not actual dominoes, they're just pieces of wood. But the principle is the same. And what these are really acting as is a simple machine called a lever. And this one's not quite as intuitive, and we didn't really talk about this much in my class. So I want to spend a little bit of time here talking about levers. So generally when we talk about levers, there's three different kinds or three different classes of levers. And all of them will have a lever arm and a fulcrum, some point where the lever arm pivots. For a first class lever, the effort, the force you apply to the lever arm is always on the opposite side of the fulcrum from the load. So in this case, you have the effort there on the left going down, and if I push down on the left side of that lever arm, the load is going to be lifted up. A classic example for a class 1 lever would be a pair of pliers or a pair of scissors. So if you think about a pair of pliers, you have a pivot point there where at the base of the jaws, you have a lever arm, really two lever arms. You're applying an effort force at one end, and then on the opposite side of the fulcrum, you have the load force. In a second class lever, big difference is that the load and the effort are on the same side of the fulcrum. So classic example of a second class lever is a wheelbarrow. So you notice that the effort which you apply to the handles of the wheelbarrow is on the same side as the fulcrum, which is your wheel, as the load, which is whatever is inside the wheelbarrow. Let's label those. You have your effort, your load, and there's your fulcrum. That's a second class lever. There's also a third class, which is similar to the second class. You have the effort and your load forces on the same side of the fulcrum, but in this case, the effort is closer to the fulcrum than the load. Whereas the second class, those were switched. The effort was further from the fulcrum. So what I think about when I think of a third class lever is there's a machine at the gym where you basically lie down on your stomach and there is a lever and you are pulling, applying an effort to a lever arm with a fulcrum. And notice the effort is closer to the fulcrum than the load. Another example would just be a pair of tweezers, right? If I squeeze a pair of tweezers, the load is the movement there at the end. My effort is closer to the base, and the fulcrum is where um, the two pieces of metal meet. Okay, so let's apply this to our dominoes, which are not really dominoes. If you think about the way a domino falls when you have them lined up, they fall without the base really moving. Um, the bottom of whatever's falling pretty much stays stationary. So you can think of that point at the bottom as the fulcrum, and the domino itself as a lever arm. And so you imagine dominoes falling, and that when one domino hits the domino in front of it, that generates the effort force, and then the motion of that domino is the load. And we generally apply motion to the center of mass of things. So for dominoes, they can really either be second class or third class levers, depending on how far you space them apart. You can imagine if they're spaced far apart, the domino is going to hit the one in front of it pretty near the base. Well, then now your effort's below where we would say the motion is, and that would be a third class lever. Um, that's kind of how dominoes act as levers. Yeah, it's kind of hard to tell from the video, but here we have a pulley, which is another type of simple machine. There's a string running over the pulley, and in each side of the string there's an aluminum can, and each can is filled with water, and one can just has slightly more than the other. So if you think about the forces acting on the cans, you have your weight, which is mass times gravitational acceleration acting downward, the tension of the string acting upward, and I put slightly more water in one can, so the masses are imbalanced, so your forces are imbalanced, and you get acceleration. Okay, so we have talked about inclined planes or ramps. We've talked about levers, pulleys. The fourth machine here is an example of a wedge. All a wedge is are two inclined planes that meet at a point, and if you apply a force to the wedge on some object, you can drive that object apart. So a knife is a classic example. You're using a wedge simple machine to drive things apart, to cut them. So the wedge in my machine is a meat cleaver, and it's also an example of a lever. Um, is taped to a piece of wood, which is a lever arm, and there's a fulcrum where the lever arm can pivot. It's propped up by a piece of wood, and once that piece of wood is removed, well, now it just becomes a pendulum with a wedge on the end. And this wedge cuts a string, which releases another aluminum can full of water. And this gets us to the final simple machine in this Rube Goldberg, which is the wheel. This is pretty straightforward. A wheel is just a circle on an axle. And there's actually a couple wheels here. If I draw a diagram of this bike, I have the wheel of the bike, obviously, but also the gears are a form of wheel. Those are connected by a chain, and the aluminum can full of water is tied to the pedal. So the pedal here is acting as a first class lever arm, and the movement of the lever arm turns the gear wheel, which turns the regular wheel, which puts the straw in the drink and completes the Rube Goldberg machine. So here's the whole thing again, from beginning to end, uninterrupted.